This is Møller Nielsen from Java Code Geeks, and I'm going to teach you how to write clean, efficient code using test containers. If you have the need to start up a Docker container before you run your unit test or your integration test because you have a dependency to, for instance, a Redis cache, then this video is definitely something for you. Now, complementary to this video, there will be related articles and links in the description below. Also, please take the time to visit javacodegeeks.com, where we have a lot of cool Java stuff. Please take the time to like, subscribe, and hit that notification bell, because we have a lot of cool stuff coming up. Now, without any further ado, let's get started. So which problem is it that test containers actually want to solve for us? It wants to solve the problem where we usually would mock off or tests in order to run some integration test that maybe reaches a Redis cache, or maybe reaches a Kafka server, or maybe a RabbitMQ server, or maybe some kind of some database system that we usually would have to use Mockito to mock us out of. Then we can use test containers instead, and then we can actually run our integration test against the real thing, so to say, against real containers that actually run on the same machine as the test actually runs on, and then we can get the result, which will be much closer to running against a live environment than if we just use the Mockito way, or the mocking way. So we have testcontainers.org. There are more languages than Java, as you can see right here. There's also an implementation for Go, .NET, Python, Node.js, and Rust. And what does test containers actually do? It integrates, and it actually reaches the Docker, the local Docker system through the API, and then it is able to start up some containers with a given set of properties, and you can also determine some extra run commands if you want to. And then it exposes a port on a random port on your local host. So that is actually what it does. Quite simple as that. So let us just look at an example just quickly right here. So we have a dependency that we have to add. If you use Gradle, you would have to copy that line right there. If you use Maven, which we are in this demonstration right here, then you would have to copy this snippet right here and then add to your pub.xml file. After doing that, you would not need this part down here. After doing that, then you could, if you have a specific test containers actually supply specific implementations of the different databases, and also for some of the message queuing systems like Kafka. But there's also generic way. So even though if there's no specific integration to these third-party systems, then you can always use the generic way and thereby just spin up an image from Docker Hub with the generic container. Or if there's a specific implementation, of course, use that, because it is much easier. There's been done some work to make it easy for it to start up. We will see examples of both of these situations in this video right here. And so this is the testcontainers.org. This is where there's a lot of documentation here. Some of it is quite good. Some of it could be a bit more specific, and I will show you some examples of the good code. And if we go look right here, this is a JF Unit 5 quick start manual right here that we have right here, and it actually says that we should annotate with test containers. There's a problem with that if you run the add container right here. It will give us a problem if you run Spring Boot, and there are a couple of workarounds which specifically Spring Boot that we can use. One of them is a dynamically assigned property source, but we will see an example of that a bit later. So here we have this is actually where the magic happens. So this is test containers. We spin up a new generic container, and then we have to give a name of which image that do we want to actually run. And this the image, of course, it can be specific with a version, with a tag. You can also just leave out the tag, and then it will be latest that would start up right here. Then the other argument that we have to give is which port is actually used inside this container. And for Redis, it is the default port is 6379. This port will then be mapped to your local host on a random port. So this means you do not know which port that you should connect to in your test. You have to get that information as part of your test, and that is exactly what happens right here. We have the address is being picked up by the generic container, which is named Redis in this situation right here. And of course, this could be anything. It could be PostgreSQL. It could be MySQL. It could be whatever, right? It could be RabbitMQ. It could be Redis. It could be Kafka. And here we get the ports that we need. So this is the host, and this is the first map port right here. If there are multiple ports that you need to map out, then all of these ports will then be mapped out to your local host to a random port on the local host. This means there can be more than one port. In all examples that I have right here, we only have one port, so it's not a problem for us. But you can get a list of the map ports anyway, and then you can just go through them one by one. So, and the order, they will actually match the order where you type them in. So that means that the order where you give the ports up here, you'll have the same order out when you get the map port out if you have multiple ports. So, and then when you're done, then you can actually use. Of course, you can call some code that actually uses this. That uses this Redis that now runs on your local machine. And then when you're done, then the test containers will clean up the container. It will stop it. It will also remove it. Actually, test containers starts up 2 containers, and we can see that in our IDE or in integrated development environment. I'm using IntelliJ. There you can see which containers are actually started up. There's one test container being started up. That's the one that actually keeps track of the other containers, and then we'll see to it that the cleaning up is done correctly. That we are deleting and stopping all of the containers that we started. So that's a quite cool things that we will actually get. The test containers actually clean up after itself. That is one of the main reasons for using test containers right here. But I have prepared some codes. So first of all, let us just close all of it, and then I'll show you my pump.xml file. In our situation, we want to create a test that uses Kafka. And we want to create a test that uses Redis. Redis is the simple one because it is just a key value store. It is a cache. It is really, really fast. One of the main purposes of Redis is that it actually has time to live on each of these properties, and that means that each of the key value items then will expire at some point, and then the cache can then be updated with newer versions. For using Kafka, with the code that I have right here, I'm using also a Kafka template. Then you have to use the Spring Kafka like this. You should not add any version. You should actually delete you should have Spring actually handle which version of Spring Kafka that you need to use. If you have typed in a version, then you probably will get a class not found exception, and then Spring Boot could not find an error handler class, so that you'll probably get that error if you added that. If you go to when you create a new project, you can choose something called Kafka Streams. It is not the same thing. It's not the same thing, just so you know. Of course, if you want to play with Kafka Streams, then of course just add Kafka Streams instead. It is just so you know that there's a difference. We have this one and we have this one right here, and we are dealing with just Apache Kafka, so Spring Kafka, Apache Kafka in this situation right here, not the Kafka Streams right there. So that is one thing that we need to, so of course we need to add all of the dependencies that we usually do to our third-party systems, but then we also have to add test containers, and we can set the scope to test, because we only need test containers when we run a test. We do not need it do not need this code to be deployed to our final version that runs out on our production system. So just set the scope to test like this. And then if you want a specific implementation, the Kafka example is with a specific implementation of a Kafka container. That's why we need this dependency right here. The Redis example that you will see is with the generic container type. So you can always start with the generic container type, but I would actually recommend you, when you have any problem, if you have any third-party dependency, I would actually go to test containers and then go to the modules and then see if there is a module that matches you. Or maybe you were using Elasticsearch. Yeah, then there's actually an example right here. If you use Nginx, then there's an Nginx implementation right here. So that means that we can actually get an Nginx container instead. This means that you will actually, there's a lot of work that you will save, and you will have a lot of things actually set up for you, and there will be some easy to use code snippets that you can just copy paste into your tests. And of course the same with RabbitMQ, Red Panda, HashiCorp Vault. So, but of course, as you can see right here, there's like 15 default modules, and then if you want something else than that, then you have to use the generic module instead. So let us go back to the code. Here we actually, this is the dependency management. We will also add the test containers bomb actually right here. So we get the right versions when we run our tests. I'm also using Lombok, just so you know. When I created this whole project is creating, it's a Spring Boot project. I created that by pressing File, New Project like this. Then I ticked off Maven. I use Java 17 compliance, and then I use JDK 19 right now. Then I press Next, and I added Lombok like that. I added Kafka like that, and I added Redis. Redis. Let's just find that. Redis. I added Redis like that, and then I added web. Then I also added Spring Web, so I could get a controller. Then I press create. Oh, I also added test containers, of course. I added test containers, which we have right here. And then I press create, and then I got this cool project right here. Then I added manually. Then I added this Kafka snippet right here, and I found that, of course, on testcontainers.org. So okay, but let us now look at some code. So that is the interesting part, right? So in this situation right here, I have a spaceship REST controller, which I have right here. Then I have a Redis configuration where I set up my Redis configuration, and here I can set an entry TTL. This means time to live. So this is how long will my key value items actually live per default before they have to be renewed. And I'm also disabling some caching null values right here. So that means that I'm not caching the null values at all. And if I actually pass a whole object, then it will actually be serialized with the action serializer right here. So that means that if I want something to be serialized into JSON, then, or if I pass it an object, it will be represented as JSON in the value area right here. That's just some minor setup things right there. And then I have my application properties right here. So Spring Redis host right now is set to localhost. This will be, or we will set, so this is what we have per default, and there's no port per default because we will set that in our tests when we come to the test area. Of course, I would need that. Of course, I would need those. Actually, the default port is 6379. So, yeah. And here we have some properties. We have a bootstrap address, which is not set per default. Then we have a group ID that I need for my Kafka, which is right here. I set that to Mike, and I also created it without all of the prefix right here. if I look at my spaceship REST controller right here, then I have that right here. I am using this cache manager, which I inject by using constructor injection right here. I have my required constructor right here. So when I say that this cache manager should be final, then I will actually have access to the cache manager inside my code. You can also use the Redis template. That is also a common way to go actually to use the Redis template instead. But in this situation right here, we use the cache manager. So we have a get mapping where we can actually get all of our spaceships right here. And inside that one, we'll actually get cache ships. We can create different caches. This is also quite important to know that we can create different caches. We can just name them whatever we want to name them. And of course, when you name them something like this, then you should use an enum instead, so you can have all of your caches in one place, and you don't do spelling mistakes like this. Of course, you can also use constants if you want to, like public final statics instead. But I would recommend you to use an enum instead of just strings. Then we return this one right here. We say cache.get, and then we say get the ships, and then we say please cast the type the return value that we get to a list. And we know that this is a list of spaceships. So that means that we're actually storing a list of JSON objects inside the value. That's actually what we are doing. So that is one call that we have in our REST controller right here. Then we have we have a request mapping of space right here. That is just so our endpoint starts with space and then all. And then we have a post mapping right here. This is where we can actually create a new ship. And my spaceship, I will just give that a captain. My spaceship does not have that many fields. It has captain, model, and fuel left. And then I'm using the builder pattern to create them. And that is part of Lombok. If you haven't seen the builder pattern, then please look into Lombok. We also have some articles with that. So here we say, first of all, we say if ships equal to null. So we start with actually getting the list right here. That is because it can actually be null. Then we place an array list inside the ships right here, and then we add one spaceship. And I'm actually only setting the captain name right here. I could also have set the other values if I want to. I could have set the fuel left to 88%, and then we could set the captain like this. And we could also have set the model, and we could set the model to maybe round, and then the captain right there. In this situation right here, we just want to we want to create different spaceships just with different captains. So the only thing that actually varies is the captain in this call right here. Then I am putting. This means I'm setting the key inside the ship's cache. Then I actually set my ships right here. So this is where I actually set. This is where where I actually store my value right here. So, and this is the key ships that we have right there, and then we also have the cache right there. Of course, it's a little bit confusing that both the cache is named ships and also the key is named ships. These names right here, this should be different. So you know that the key right here, ships, is not the same as this as the cache name. You can have multiple cache names. It's kind of like you can have different schemas when you're dealing with a database or a relational database. And then when we're done with actually storing this new ship in the ship's array list right here, then we actually return all of this. Then we actually call this method up here, where we return all of our spaceships. So those are the two methods that we would like to test, and of course we would like to use test containers, since this is what the video is about, right? And before we had test containers, we could do two things. We could spin it up manually. We could spin up a Redis instance manually somewhere, and then just say that we leave it open for when we're running integration tests. Another situation is that we could actually have mocked the whole Redis. The whole Redis integration. We could also have used an embedded Redis database. That's also a way to go. The reason why I would say that it's better to have an external Redis is that it is easier to scale. If you use the embedded Redis, then it's difficult to scale. That's the only thing about that. But embedded, and the embedded Redis, it stopped to be supported at some point. So let us just. I'm actually not. Yeah. So that's. So then we have the. So this is our test right here. We have the Redis test. And if you just read the documentation, if you read the default documentation, then you see this container part right here. We cannot use that when we are dealing with a Spring Boot test. That's why I have left the code out commented, so we can see that we cannot use this default code right here. Because what will actually happen is that first our Spring Boot context will start, and then this container will start afterwards. This means that all of our properties will already have been set. We will already have connected to, so that means that when we connect to the Redis database, then we will connect with to the wrong port, and we will actually get an error. So what we need to do instead is there are two approaches. One is to use the static approach, where we run some static code, and where we also start the code manually. And there's actually three approaches. So we have one, two of them actually resembles each other. That is the static approach, and then the before all is actually run before the Spring context runs. So that means that this code is actually run before our Spring Boot application context is up and running. Another way, and this is because it's static. So actually, anything with static right here, we would actually make this Redis code run before the Spring context right here. I could also have deleted. the before like this, and then if we could have had a static code block instead, that this would also be okay. Then we would start our Redis container before the Spring Boot container would start. And as we can see right here, this is the generic container. And the generic container, it's quite simple actually. We just say we want to have a Docker image name, and usually And I've just chosen Redis. That means that I've not any tag. I've not added any tag. That means that per default, latest will actually be used. And of course it's up to you. Of course you can add your tag version here if you want to. This then we say please expose port 6379. And then it will be exposed to a random local port. So that means that we do not know which port this will be exposed to. So we have to get that port. And in this solution right here, we're actually setting a system property, because Spring Boot actually it overrides its own properties if you set the system property, or if you set a command line property, that would actually be, or that would actually override the system property. So this system property right here will override the property from the application, the properties files. And here we get the host, so that means I'm setting the Spring Redis host. And here I'm getting the port. And here we get the port right here, get map ports. And then we can say the original port, and then we can actually run into string on that. And let us also log it out actually. So let us just system out, printline it, and let's say the local ports mapped to 6379 is, and then we add that part right there. So that means that now we will just get it in our console output. Of course, we could also use the real logger, the SL4J. So, and then we have after all. So what do we do when we're done? We actually stop our Redis instance right here. Quite cool. Here comes the real test. So this is actually the test code that we want to run. First of all, we want to list all of our spaceships, and we the first count, it could be 0, and it could also be if it was not null, then we set the first count to something, or else it was just 0 to begin with. Then we create a new ship right here. So we create a new ship with the Captain Mike. And then we count all of the spaceships. Once again, we get all of our spaceships. And then we say, here's the second count. And then we assert that the first count plus 1 should be equal to the second count, because we only create one spaceship. And then in the end, I print out all of the spaceships just so we can get a string representation of the spaceships. Let us see what happens when we run this code. So I'll just press play, and we will see if it actually works. It did not. Because I have a Kafka bootstrap address error right there. Not so. Yeah, this is a Kafka bootstrap address right here. This is because I just made some last-minute changes. So yeah, this parameter right here should be named Kafka bootstrap address, and this is because I changed this property name in the configuration of the Kafka example. This is not the Kafka example I want to show right now. So let us just yes. So the problems right now is that then we have the bootstrap servers right here, and we just set it to localhost. The problem now is that we actually have two tests, and in one of them we want to run an integration with Redis, and the other one we want to run an integration with Kafka. So let us just we will actually take the Kafka code, and then we'll annotate that with. Then we'll annotate that with active profile. The way to actually handle this is actually to use to set a profile on top. So we'll say profile like this. This means that this requires a profile Kafka. So this means that if I have not enabled the Kafka profile, then all of this code right here will actually not be run. And of course, when we run our Kafka example in just a couple of minutes, then we will then set the active profile to Kafka. So let us see what happens now. Yes, now our Spring context actually start up. Okay, now as you can see actually here what actually happened. So first of all, we have our test containers right here that starts up with Redis. And these lines are here is because you could actually inject your own XML and configuration files to the Redis container, but we have not done that. And then then the Redis is starting up, and what we have here is a lot of Redis stuff right here, and then yes, then we start up our connection. And then if we go to the end, which is the important part right here, and then we say, yeah, this is when we're closing the connection again. So let us just see the test right here. Our test is screen, and we can see that we actually have stored one spaceship in our test. So our test works just as expected right here. We have the Redis test right here. And just for fun, let us create another spaceship right here. So I'll duplicate this line. And we don't need the return list. We don't care about the return list right here because we are getting the return list once again. And this time, let us just see the output again this time, because what I want to press the services pane at some point so we can actually see what is going on in the end. Now we got an error because we expected one, but we actually got two. And that is because we should actually expect to have two more spaceships than the first count when we end up right here. So let us just run again and see what happens. Yes, now our test is again green, and now we have two spaceships, one with Susan as captain and one with Mike as captain. That is quite cool. So now I'll press play, and then I will go to my services, and here we can see this is my Docker container. So here we can see now we got two containers, test containers, and then we got the other containers, and now it stops because it is quite fast actually. So, and the test container should also stop. Yeah, there it stopped. So it takes some time before it closes down. But now all of the containers are actually stopped, and that is why, because it cleans up after itself, and that is one of the cool things about the test containers. And again, if you just look at run, then we can see, of course, it's still green. So that was the Redis. So just for fun, so we don't get in any trouble, then I would also add a profile on top of my Redis configuration right here. I'll set this to Redis, and we'll do the same. Yeah, that's actually okay. Actually, I don't think we'll end up in any problems, because it's only if we trigger this controller right here that we would actually use all of the Redis part. But let us just add this profile just to make sure that any of this code will not be called when we run off Kafka example now. Because now we want to run the Kafka, and that is a bit more complex. Kafka is actually quite complex to set up and to start up. If you want to play around with asynchronous communication, then I would actually recommend you to start with RabbitMQ instead. It is easier to spin up, especially with Kafka. If you try to start it up yourself with the zookeeper, then it can be quite complex, at least to start up. Of course, if you use the test containers, then it's quite easy, because they have created their own Kafka container. So they have created their own implementation. And that is one of the really good things about that. So I'll say active profile now. And then here we will say Kafka. This means that all of our Kafka setup and all of the controllers that all of our configuration is actually called. And then we let us go through the code one step at a time, so we can actually see what's going on. So first here we have the static Kafka container right here, and then we call before all right here, where we start up our Kafka container. The Kafka container is defined right here, where we say this should follow this Docker image right here, and this is a Docker image that was on the best practice in the documentation of this Kafka container on testcontainers.org's webpage. So that is where this. That is where I found this image right here. But of course, you can try your own images also. And then one of the differences between Kafka container and the generic container is that the Kafka container can be asked for Bootstrap servers, and Bootstrap servers are exactly what we need when we connect to when we want to connect to a Kafka server. Then we need the Bootstrap server to go through, and this is how to get that. And here I set that system property right here, Kafka bootstrap address, and then we get that right there. And of course, I also print it out so we can see it in the output. Then the test itself, let me just delete these 3 lines right here. The test itself is right here. We are sending 3 messages on something called a topic. A topic is something that you can follow. So this means that if you are listening on a certain topic, then you only get messages that are sent to that topic. And I'm going to send 2 messages to the Mike topic, and then I'm sending 1 to Susan topic. My listener that I'm defining in my application is only listening for Mike topic. So that means that we will only see the first message, the second message. We will not see the third message. However, we are going to sleep a bit. So and the reason why we do that right here is because we do not want to stop our application right away. We want the listener to have time to react to the message and then print it out in the console. And then while we are waiting anyway, we are going through this loop 400 times, and we wait 10 milliseconds every time. This means that we actually wait 4 seconds all in all. Then I say every 50th run through, then I actually say that please send another message right here. Then I send 1 to the topic Mike, and then I write this message right here. Yeah, so this is the test code. Now let us look at the Kafka. Let us look at the Kafka configuration, because we both need to configure the producer, and we also need to configure the consumer. So the producer is right here. Here we have a producer factory, and we are giving some information about how should we serialize information onto the Kafka topic. And then we are defining, this is the most important part actually, with this template right here. This is the one that we use this is one we use to send our messages to the Kafka topic. Then we have Kafka topic configuration right here. This is because that we need to create the topic when our Kafka server starts up. In old days, you would have to run some commands, but actually now they have something called a Kafka admin. So this is something that we can connect to through Spring Boot. This means that we are creating this. We're actually running whatever code we have in here, and here we have a topic, new topic right here, and this is Mike's topic, and here we return new topic, and then the name Mike, and we just have one partition. That's the only thing. That's okay, and then. So this means we're actually creating this topic whenever we start whenever we start up. And then we have the Kafka admin right here, where we can set the bootstrap address, which is right there. And this is the one that we are all writing in our test. Just so before we start up our Spring context, then we are actually setting this value right here. Yeah. So far so good. Let us now run the test, because this was the topic configuration, the consumer configuration right here, and here we haven't gone through the listener actually yet. So let us just do that. So here we have the consumer configuration. Here we set up some consumer stuff. We set up a concurrent Kafka listener factory. So you need to know that you can configure stuff there, that you can read that in documentation, of course. And there's also a consumer factory right here that you can set up. And of course, here you need to give the same information. They need to have a bootstrap address, and also something called a group ID. The group ID is a logical organization of the consumers. So that means that you can have multiple consumers that that are all in the same group ID. The group ID that I'm using is just Mike with a capital M again. So I could have also called it a Mike group. But we see it a couple of places. We see it in the consumer right there, and then we see it in the listener right here. The listener, this is actually where we this is a fun part. This is where we actually can handle each message, and we will actually listen for a message, and then we can. Right now I'm just printing it out to the console or to the log, and here we say, yes, we received a message in group Mike with topic. Sorry, misspelling there. With topic Mike, and then plus message like that. So that means that then we can actually print out each of those messages. And we have to annotate with Kafka listener, of course, and we also have to annotate the whole class with a configuration, or else Spring Boot will not look at this method inside this class right here. So now we are ready to run the Kafka test. Let us start. Run. Let us then see what kind of output we will get. There's a lot of output in the Kafka, and that's also because the logging per default is debug. Of course, that can be changed, but per default is debug. And I will recommend you to just keep it at debug to begin with. So then you can always set it to info later on if you feel that it is disturbing for you. Remember, it's only when you run your tests that you use Testcontainer, so it should not be that annoying. There's also a lot of Spring context set up right here that we can see, and then in the end right here we say, yes, we received the first message, the second message, and then we got one message for 0, 50, 100, 150, and 200, and 250, and 300, and 350. So that means that my Kafka listener actually works, right? So that is quite cool. It is quite cool what we have set up right here. And if you don't know it, this is a good trick if you want something to happen on the 50th run, or on the 20th run or something like that. Then you just change the number right here to whenever it should actually react. We can set it to 25 if we should instead. This is the modulus, so that means that it will give us it would divide where we are right now with 25, and then it will give us the rest and then we say that leftover, that rest need to be 0. So that's how we do that. So that means that when I is 0, then there's 0 left. If it's 1, then there's actually 1 left. And then when we come to 25, then of course it is again there's 0 left when we divided I with 25, and then again we call this code right here. Now let us just, for fun, let us just press play once again, and then we want to let's just see the output again this time, and then we want to see the I'll run it a third time, and then we will see the containers, the Docker containers. So here now we can actually see that now we will actually get a message per 25 time per every 25 times. So we are running through this loop right here. I'm pressing play again, and then I want to press the services as fast as possible. And now we can see we have test containers right there. We have the Kafka right here, and we can actually see the output is actually in each of those right there. So that is the test containers, and this is the this is a Kafka. So, and then at some point when it's done, then these will also be stopped again. So now they have been stopped and everything is cleaned up and everything is fine. So I promised you something with some dynamic resources and properties. So let us look at that approach instead. So instead of calling before all, and instead of using the static code approach up here when we actually start Kafka, then we can use this setup where we're actually changing the properties. And there's a cool example. Again, this is from the documentation where where there's a lot of cool code examples. Here we have it. So this is the Spring Boot. So they have created an abstract class right here. You could of course just place this code in your regular class, and then you'll get the same result. And they're using the Redis example right here. So this means that they are creating the new Redis with the static actually still. Then they are still running in a static. They're still running in a static context, so to say, Redis properties. But then they're annotating with dynamic property source. And this means that this is actually a way where Spring Boot can be told to change its context properties on the fly whenever it's running. And here we start the Redis, and then we add to the registry. You can see here we have the dynamic property registry right here. Here we then add each of these properties right here, the Redis host, and the Redis port is added from the Redis get first map port method right there. So that is quite awesome. And again, this is a method reference, as you can see right here. It's not the value itself; it is a method reference. This means that that the value will actually be whenever the value is needed, then it will actually be picked up by calling that method. So we will not call the method right here. We will call the method when the property is needed. That is quite that is quite powerful. So that is test containers. I hope you liked this video. If you did, then please like, subscribe, and hit that notification bell, because we have a lot of cool stuff coming up. Bye.